Okay, class, today we're going to start the chapter on logic. I'm going to warn you guys right now, this is a challenging topic only because most people have never had it. It is a math topic, believe it or not, and especially later on in mathematics, you do use a lot of logic and the symbology that we're going to be using here, but it'll be new to a lot of you, so I'm anticipating a little bit of help that will be needed in this section, and that's okay. I can set up some Zoom meetings with you guys, or on Wednesday we can get a lot of questions answered next week as well. I'm going to start off with some definitions, okay? So first of all, definition number one, okay? A statement, we're going to first define what a statement is in logic. A statement is a sentence that is either true or false. But not both. Okay, so has to be either true or false. So an example of something that's a statement is I am 6'9". That's a statement. Okay, a statement doesn't have to be true. It just has to be a declarative fact that could either be true or false. Okay, so this is a statement. This is not a statement. Okay, read the textbook. That is not a statement. That's a command or an order. Or another statement, another thing that would not be a statement is something like The Matrix is the greatest movie of all time. Okay, that's not a statement because it's an opinion. So opinions are not statements. Or another sentence that's not a statement is, what time is it? That's a question. So 3 examples of things that are not statements would be opinions, commands, or questions. Okay? But anything else that's a declarative, a potential fact that could be true or false would be a statement. Okay? So we normally identify statements with letters, okay? So I could say, let's do a statement that I'm going to call P. London is in England. Okay, that is a statement. It's either true or false, okay? So that's the statement P. If I want to negate that statement, that means that I say the opposite of that statement. And we use the symbol, this little squiggly here means not P. This is the symbol that means not. That's squiggly. Yeah, we're learning a lot of notation here. And not P would mean that London is not in England. Okay, so it just negate the truthfulness of it. And so we'll oftentimes use the not symbol to negate a statement. Okay. So now there's some logical statements that are very, very common that we will use a lot in this class. Okay. Okay, we call these statements quantified statements. And quantified statements are just statements that have an all or a some or a not or some of those things in them. And they do not have to be true statements. This is really important in logic, guys. A statement is a statement even if it's false. Okay, it could be false. It just has to be the kind of statement that you could determine whether it is true or false or not. So these are the common ones here. All A are B, some A are B, no A are B, and some A are not B. Okay? So there's some equivalent ways we can say these in English, okay? And those equivalent ways we could say them in English are there are no A that are not B. Another way to say some A are B, some basically means that there's at least one A that is a B. Okay, at least one A. So you see the equivalencies here. All poets are writers. There are no poets that are not writers. Those are logically equivalent. They mean the same thing, right, in English. Some people are bigots. could also be said, at least one person is a bigot. So no A are B means that all A are not B. That sounds like contradictory, but take a look at no common colds are fatal. That means that all common colds are not fatal. If you actually see it in that context, you can see those are equivalent statements. They mean the same thing in English. Not all A are B is the same as some A are not B. So these are equivalent. Some students do not work hard means that not all students work hard. Okay, so they're kind of giving you some examples with some actual statements. So the reason why it's called quantified is because they're speaking about sort of, in a sense, numbers of things. Okay, so the quantifiers, we call the quantifiers that we use are all, some, and no are the quantifiers. Sometimes none. Okay? Those are the quantifiers, and then the quantified statement. These are the actual quantified statements here. Okay? In this table. So that gives us an introduction to quantified statements. Okay, let's look at a statement. P. Notice I use P here. As this, we're going to call this statement the statement P. All ravens are black. Let's say I wanted to find the negation, the not P. What would not P be? Okay, so the negation of that statement. This means the negation of. Let's negate that statement, or the not version of it. Okay. Well, if all ravens are black, what would, basically when you want to negate a statement, you want to create a statement that would prove beyond the shadow of a doubt that the statement that we have written there, all ravens are black, is not true. Well, wouldn't that be, to prove this wrong, I'd have to find at least one raven is not black. Right? Wouldn't that be the negation? At least one raven is not black. If I'm telling you that all ravens are black, if you wanted to prove that statement false, you'd say at least one raven. You'd have to show me that at least one raven is not black. Another way to say this is, okay, so this is one way to say it. The simpler way to say it is some ravens are not black. Some ravens are not black. These mean the same thing. These are the same thing. Some ravens are not black means that there's some. Some could mean one or more. Okay? So at least one raven is not black. Okay, so that'd be a way that we would negate that. Let's erase this. Let's do some more examples of negation. Okay? Trying to get a lot of examples here for you. I know these are kind of confusing. Okay, let's take a look at this statement P. Some dogs weigh over 100 pounds. So let's negate that statement. Let's do the opposite of that statement. So again, the question I want to ask is, if you asserted that some dogs weigh over 100 pounds and I wanted to prove you wrong, I'd have to say that all dogs don't, or let's write it another way. All dogs are not over 100 pounds, wouldn't I? So that would be the only thing that would prove it wrong. If you're saying, because you're basically saying, when you say some, you're saying at least one. Okay, because remember that some means the same thing as at least one. Those mean the same thing, some and at least one. So if I say some dogs weigh over 100 pounds, the only way you could prove me wrong is to show to me that all dogs are not over 100 pounds. Okay? So that's how I negate that statement. So another way to think about this, let's do the same example again. Some dogs weigh over 100 pounds, okay? Another way to write this, which is equivalent to what we just wrote, is that I could say no dogs weigh over 100 pounds. Wouldn't that be the opposite? This means that at least one dog weighs over 100 pounds. The only way to prove that wrong is to show me that no dogs weigh over 100 pounds. So when you're negating a statement, you're trying to find a statement that, let's say in a court of law, would prove this other statement false. Has to prove it beyond a shadow of a doubt that the other statement is false. Okay, so that's how to negate those two statements. Okay, I'm going to give you my Easter egg for this video, folks. And the Easter egg is 234111. 234111. Okay, so we're going to take this statement now. All journalists are writers, and we're going to do two different things for this one. We're going to first rewrite this statement in a different wording that means the same thing. So to say all journalists are writers, if you go back to that initial table that I put up that showed the different ways to write these quantifying statements, if you go back and review that table, another way I could write all journalists are writers is to say that no journalists are not writers. If you remember from elementary school, that's a double negative, isn't it? But those mean the same thing, because if no journalists are not writers, that means that all journalists have to be writers. So that double negative means that they kind of cancel each other out, right? So that means that all journalists are writers. So that'd be a way I could rewrite it. In the homework, they're going to ask you to rewrite these statements so that they mean the same thing but have a different wording. That'll be part A for several of the problems. Okay, now let's negate this original statement, not P. Let's negate it. So all journalists are writers. If I wanted to prove that wrong, I could say at least one journalist is not a writer. Correct? Couldn't I say that? Because as soon as I show that there's at least one journalist that is not a writer, I've proven the statement wrong, that all journalists are writers. Another way to write this, not P, is I could say some journalists are not writers. That's how I would negate that statement. Okay? Okay, let's take a look at this example, P. This statement, there are no applicants who were not hired. Okay, notice that this statement, let's rewrite this statement in another way. That means the same thing. Notice the double negative. The double negatives kind of cancel each other out. That turns this into an all statement. Okay, so another way to write this is all applicants were hired. Because if there were no applicants who were not hired, that means that all applicants were hired. So that is the same. These are logically equivalent statements. These mean the same thing in different wording. Now, if I do not P, if I wanted to prove this statement wrong, all applicants were hired, I have to find at least one applicant was not hired, right? That'd be the logical negation. At least one applicant was not hired, or put another way, at least one just means the same as what? Some. Some just means one or more, or at least one. Some applicants were not hired. Okay, so either one of these is not P. I'd accept either one, by the way. Okay, that kind of goes through those. This is a great example here. This is a summary table of how to negate different types of statements. So starting with this one, all A are B can be negated as this, some A are not B. So if I say all ravens are black, the way I negate that or prove it wrong is to say some ravens are not black, right? That's the opposite. You know, that proves the first statement wrong. I could also go the other direction. If I gave you the statement, some ravens are not black, you could negate it by saying all ravens are black. So these arrows go both ways, folks. You can negate, let me just delete this a minute. Whoops. Didn't mean to erase that table. I had to put it back in there. You can negate all A or B to get this, okay? But you could also negate some A or not B to go backwards and get that. They negate each other. Same here. Some A or B negates as no A or B, and no A or B negates to some A or B. And they show you some of these examples over here in this part, okay? So that should get you started on this homework. And again, you may have some questions, but I don't think this is going to be a really, really challenging homework, the first section here. I'm going to do a second video on section 3.2. It will not have an Easter egg in it. I only have one Easter egg per day.